Hello students, today is lecture 8 of periodic properties. Today we will discuss about the periodic trends of electron affinity and electron negativity. Electron affinity. Electron affinity is defined as the energy change that occurs when an electron is acquired by a neutral atom. Most atoms release energy when they acquire an electron. The quantity of energy is released is represented by a negative number. So usually when energy is released during addition of electron, it is shown by a negative number. More the negative value, that means more the electron affinity. Some atom must be forced to gain an electron by the addition of energy. The quantity of energy absorbed is represented by a positive number. That means if some atom is not having tendency for the electron affinity, then it will not keep electron tightly attached with it. In that case, some extra amount of energy is required so that that extra electron forcefully attached with that particular atom. In that case, the change in energy is in a positive value. Electron affinity is actually the measure of the tightness holding of an extra electron to an atom. That means if extra electron comes into the atom, comes into the orbital of an atom, then how much tightly that atom holds that extra electron. It is represented by the electron affinity. Just like ionization energy values, electron affinity is also measured as first electron affinity, second electron affinity, and so on. So first electron affinity, that means the tightness in holding of extra electron if one electrons enter into the orbital of an atom. Similarly, second electron affinity, that means when second electron enters into the atom, then how the atom showing tendency to tightly hold that extra electron, that is the second electron affinity. So usually the first electron affinity shows a negative value because electron easily enters and the nucleus tightly hold that electron. But it is quite difficult to hold electron with same affinity if that electron is second number electron. So usually the second case is that case when the atom is forced to gain an electron, and that's why usually the first electron affinity is having a negative value and second electron affinity is having a positive value. More the negative value, more will be the electron affinity. More the positive value, less the value of the electron affinity or less electron affinity. So, and electron affinity is generally represented as E or EA and is measured in electron volt EV or kilocalories per mole. The magnitude of electron affinity depends on a number of factors such as atomic size, effective nuclear charge, electronic configuration, screening effect, and shape of orbital. In case of atomic size, if the size of the atom is smaller, then the distance between the extra electron which is added from outside and the nucleus of the atom is lesser. Therefore, the electrostatic force of attraction will be more between that extra electron and nucleus. And that's why if the atomic size is small, the electron affinity will be higher. In case of effective nuclear charge, more the nuclear charge, more strongly it will attract the additional electron. Therefore, the electron affinity increases with increase in effective nuclear charge. In case of electronic configuration, atom having stable electronic configuration. Stable electronic configuration, that means either half-filled or full-filled outer orbital. These are known as stable configurations. So, if the atom is having stable electronic configuration, then it will not show much tendency to add extra electron. And so, these type of atoms which are having stable configuration, they have very low electron affinity. Then another factor is screening effect. So as you know that if more is screening effect, in that case the effective nuclear charge for the outer electron is decreases. That means it decreases the electron affinity, because electrons which are present between that extra electron which is entering in outermost orbital and nucleus, the electrons which are present in between these two screen the attraction between the electron and nucleus. Then next is shape of orbital. We already discussed that the electron cloud in s orbital is distributed equally, and then it is closer with the nucleus as comparison to the p and d orbitals. So if the incoming electron is coming in s orbital, in that case the electron affinity is higher, and if it is entering into the d or p orbital, in that case the electron affinity is lower comparatively. Electron affinity trend in periodic table. Here in this diagram you can see that if we are talking for a group, then electron affinity decreases on going down in a group. This is because electron affinity is dependent on size, and we know that if size is smaller, then electron affinity is higher, because the distance between the nucleus and electron which is entering is low, and then the nucleus will attract more firmly that electron. So the electron affinity decreases with the size, and when we move down in a group the size increases. So if size increases, then obviously the electron affinity decreases. But there is exceptions in group 3 and group 2, that the member of third period have somewhat higher value than the member in the second period. This unexpected behavior is explained that the atomic size of member of second period, that means if we are talking about the alkali metals, in that case the lithium is very small, and due to this smaller size, addition of extra electron is resisted, and hence the electron affinity value is low for the second period as compared to the third. If we are talking about variation along a period, in that case it increases when we move from left to right. sorry, here it is written group, instead of group it should be period. So when we move forward or move from left to right, the electron affinity increases. This is because when we move forward, what happened? The positive charge increases and the size decreases. Positive charge in the nucleus increases and the size of atom decreases. Both these factors results into greater attraction for the incoming electron. So when we move forward or move from left to right in a period, the electron affinity increases. Also, electron affinity trend shows a diagonal behavior and it increases likewise. Electronegativity. Electronegativity provides a qualitative measure of the ability of an atom in a chemical compound to attract shared pair of electron towards itself. Here it should be noticed that it is a qualitative measure. It is not a quantitative measure like electron affinity, electron ionization energy, etc. So basically the electronegativity can be explained as the tendency of an atom of a molecule to attract the shared pair of electron towards itself in a covalent bond. Here you can see that example of two covalent molecules are given. The first one is HCl and the second one is H2. So here you can see that H and Cl both are having different electronegativity and the electron cloud is more shifted towards the chlorine. So it shows that the Cl atom is having more electronegativity because the electron cloud is more shifted towards the Cl atom. That's why it is having a delta negative charge and the H is having a delta positive charge, and it shows that as compared to the Cl, the H is quite electropositive. Here in H2 molecule, both hydrogen are having same electronegativity, so the electron cloud is distributed equally between these two hydrogen atoms. So by this way we can decide that which one is more electronegative. The electron pair shifted towards which atom, that atom is more electronegative. Electronegativity trends in periodic table. In a period, electronegativity increases on moving across a period from left to right. That means here in this periodic table, the electronegativity increases when we move towards right side. It is mainly due to decrease in atomic size. When atomic size decreases and effective nuclear charge increases, the nucleus having more tendency to attract the electron. That's why in a period the electronegativity increases when we move forward. In case of group, the electronegativity generally decreases from top to bottom. That means when we move down, the electronegativity decreases, and this is because of increase in size. When size increases, the nucleus is having low tendency to attract the bonding electron. So in a group, when we move down, the electronegativity generally decreases. Metallic property is related to the electronegativity, and non-metallic elements have strong tendency to gain electron. it shows that electronegativity is directly related to non-metallic properties of the elements, and increase in electronegativity along a period is accompanied by increase in non-metallic character. That means when we move forward in a period, the electronegativity increases, and as electronegativity increases, the non-metallic properties increases. That's why the elements which are present on right side of the periodic table are mostly non-metallic in nature. Similarly, the decrease in electronegativity is accompanied by decrease in non-metallic character or increase in metallic character of the element. That's why the elements which are present on left side of the periodic table are mostly metallic in nature. For example, fluorine with highest electronegativity is the most non-metallic element, whereas the cesium, which is the lowest electronegativity, which is having the lowest electronegativity, is the most metallic element. The element with the high electronegativity on the right hand side of the periodic table are non-metallic elements, and on the left hand side are metallic elements. Most of the time what happened, the students got confused between the electronegativity and electron affinity, because in both the cases what happened, we are talking about the attraction of electron by the nucleus. Clear? So here a comparison chart between the electronegativity and electron affinity is given, and we will discuss point wise. So the first difference between the electronegativity and electron affinity is electronegativity is the ability of atom to attract electron from outside. That means if electron pair is present between two atoms, then how the particular atom is having tendency to attract that electron cloud only. There is nothing that electron will enter into the atom's orbital. Whereas in case of electron affinity, it is the amount of energy which is released when a neutral atom or molecule gains an extra electron from outside. So in case of electron affinity, it shows the tendency to attract the electron which is coming inside the orbital of atom, and how tightly the atom is able to hold that extra electron in its orbital. So in case of electronegativity, it is attraction for electron which is present outside the atom, whereas in case of electron affinity, it is attraction for the electron which is extra electron and coming inside the orbital of that atom. The second point is that electronegativity is a qualitative property. That means there is nothing, no value by which we can define the electronegativity. So it is a qualitative property. That means if we are comparing between the two elements, then one is having more electronegativity, another is having less electronegativity. But the electron affinity is quantitative property, and each and every element is having a definite value of the electron affinity. Usually the electronegativity is measured from the Pauling unit. Pauling, later on Pauling gave some units for the measurement of the electronegativity, but it is not the values like electron volt or calorie, etc. So it is totally a qualitative value. And in case of electron affinity, it is measured either in electron volt or kilojoule per mole. Electronegativity is applied for a single atom, and electron affinity can be applied for either an atom or a molecule. So these are the basic difference between the electronegativity and electron affinity. This is all for today, and I hope you enjoyed the lecture. Thank you.